In this video, we're going to be talking about function notation. Now, function notation is where we have f of x, and sometimes it's even written as g of x. You say it, f of x. But as we look at how it's presented to us, we see we have an f, a parentheses, an x, and then a closed parentheses. And again, we say it, f of x. So it's a function of x. Sometimes it can be pretty confusing, and it kind of means the same thing as y equals when you're doing stuff to it algebraically or mathematically or solving for it or evaluating. Those pieces all work the same. I like to think of it as a big kid way or a grown-up way of saying y equals. So let's go ahead and let's practice evaluating. So here we have a function, and our function is f of x equals 10 minus 3x squared. Notice how that's kind of the same as y equals 10 minus 3x squared? All right, so it's going to ask us in different ways to start evaluating. Notice how when we look at letter A, it says f of x, right? F of x. Let's do it in a different color. F of x, or f of 2. But notice that the 2 is in the x's spot. So what that means is everywhere that we see an x in our equation, we are going to replace that with the 2. So for example, if we have f of 2, we'll write 10 minus 3 times 2 quantity squared. Notice how I took that 2 and put it in the x's spot. Then we'll work out that side of the equation, and we'll see that f of 2 equals negative 2. And we're done. So let's try it on this next one. So here we have f of negative 4. So where do you think that negative 4 is going to go? Yep, it's going to go in the x's spot. So now if we're looking at f of negative 4, it'll be 10 minus 3 times the quantity negative 4 squared. It's really important to make sure that you're using parentheses when you're substituting in your number. So here, our f of negative 4 is going to give us a value of negative 38. And that's our solution. So let's take a look at our next one, because it's a little bit different. Now it says f of x minus 1. You're going to do the exact same thing with it. So we have f of x minus 1 equals 10 minus 3 parentheses x minus 1 quantity squared. So notice I still put it in the x's spot. It's just what we have to do with it that's a little bit different. Notice that here we have this x minus 1 quantity squared. So we kind of need to distribute that, FOIL that out. So I'm going to make a workspace right there, where I'm going to take my x minus 1 and my x minus 1. And remember that that's where I got that from, right? Right there. That's the same thing. And I'm going to go ahead and I'm going to distribute that out. And that's going to give me x squared minus x plus 1, or rather x squared plus, sorry, let's try that again, x squared minus 2x plus 1. So now this piece right here is what's going to go in that spot. So now we have f of x minus 1. In fact, you don't even have to write that till you're ready to go. So we have 10 minus 3 times x squared minus 2x plus 1. Then we're going to need to distribute that negative 3. And when we distribute that, we're going to have 10 minus 3x squared plus 6x minus 3. And then we just need to combine our like terms to get our final answer. So we're going to have f of x minus 1 equals negative 3x squared plus 6x plus 7. And that is going to be our final answer. So it still worked the same, even though we were plugging in x minus 1 about, like, where did you plug it in? The only difference was that instead of it being a value, a whole number, like a number that we could just square and get a number, we had to do some algebra to move it along. But function notation is really easy and works pretty much the same as a y equals.